So I don't know when you're watching this video, but I would hope that you would have watched the previous video, video 1. And furthermore, depending on how much time has gone by, you're going to want to take a moment to look at problem 2 and review it quickly, just to see what we did there. Because problem 3 is the complete opposite. And honestly, problem 2 is easier than problem 3. Problem 3 requires you to be a bit more careful with what you do. So, notice that for problem 3, we don't have single logarithms. We have, in most cases, many logarithms. And we're going to express everything as a single logarithm, so we're going backwards. So let's start with part A. Notice that they have the same base. It's actually a common base because it's not showing there, base 10. There's an addition. Addition is multiplication. So I can rewrite A as log x y. That's it. And if you want to get more technical, you can. So if you want to put parentheses to make sure that your argument is just 1, perfect. Okay. A is done. B, well, it's a minus. Now, I'm going to give you a unofficial mathematical trick that works. Okay, a little bit of bootleg math. Whenever you see a minus, that's where your fraction begins. Okay, so in other words, everything to the left is the numerator, everything to the right is the denominator. You're going to see that with some other ones later on where the minuses are in different places. So with that being said, I have log base 3. Let me draw my fraction bar. And the x is the numerator. And the 5 is the denominator. And again, if you want to be nice and formal about it, put them all in parentheses to signify that you have one argument for one logarithm, right? Because we're writing this as a single logarithm, and there it is. Remember, the bulk of logarithms is rearranging parts or using properties to go ahead and get something that we can use to then get an answer from the calculator. So we're not doing a lot of math. I promise you some math later on, some algebra, but we're mostly just rearranging things. So please take some time to understand how to rearrange things. Part C, there is no plus and there is no minus. So you're not multiplying and you're not dividing. However, you do have a number in front. That number can go back up as a power. This property in particular is going to be useful in calculus. So just remember some of these things. Okay, part D. Let's note a few things. And sometimes it actually helps to use words. So before you actually tackle a problem, look at it and use words to describe what's happening. So for example, I have an addition here, right? I have a subtraction here. And then there's this 5, right, in front. 5 in front, if you can even read that. 5, that's a 5, don't hate. Stop hating. 5 in front. Okay. That looks like sin front. Okay. Now, with these words in place, look back at the previous video or the other part of your notes and note what the corresponding property is, right? If I add, I multiply. If I subtract, I divide. If I have a number in front, it goes up as a power. So this is pretty much telling you what to do. Well, instead of adding, I'm going to multiply. Instead of being in front, it's going to go back up as a power. And this 5 only belongs to this y. It doesn't belong to the x. It doesn't belong to the z. And then subtraction implies some division. Now remember what I told you earlier. Where the subtraction, where your first subtraction begins is where the fraction begins. So keep in mind that this is going to be in the top in the numerator and this will be in the denominator. So what do we have? We have log. Let's just draw a fraction bar. And we have, so all this is going to top, x, y, but the 5 goes to the y. Why? Because, well, it's adding. Addition is multiplication. This 5, if this had a 5 and this had a 5, then you could do that. But we don't have that. So don't do that. Great. And what goes on the bottom? The z. That's a good problem, folks. That's on a scale from 1 to 10 for a logarithm properties problem in our class. That's probably like a 7 or an 8. That's a pretty good beefy problem. Okay, you might want to pause and rewatch that or see what we do with the next ones. Haha, E is fun. This one always throws people off because like what? Okay. Again, there's let's look for numbers in front. There's none of them, right? We see an addition. We see a subtraction. These are skills, addition, subtraction are skills you picked up since first grade. So you got this. You got this. Stop. You got this. Okay. Now, the idea here is if it's addition, we multiply. If it's subtraction, we divide. And then, on top of that, when we do divide, I'm having some technical issues here. Wherever the minus first appears is where the fraction begins. So everything to the left, this is going to be the numerator, and this is going to be the numerator. These are numerator. And then this is going to be my denominator. So I have log base 23. I have a fraction at some point. This is a plus, so that's a multiplication. That's 10 times 3 in the numerator. And the denominator is going to be a 6. Again, note, there's no algebra. Right? There's no mathematical computation. We don't even have a calculator at this point. We are simply rearranging things, moving things around. Now, this is interesting because all the previous problems we had variables and letters that had no values, but here there are no letters. So we could actually simplify this. And before you get concerned about it, well, let's just simplify it like regular. What's 10 times 3? That's 30. 30 divided by 6, well, that's 5. So this becomes log base 23, 5. Now, on a side note, if I wanted to go ahead and put this in a calculator, I can. Yes, I can. But if your calculator, if you're using decimals, for example, right? If your calculator doesn't have base 23, then you would use the change of base formula. And then you can put that in a calculator and get some kind of a decimal number. Okay, so that's how you would do it in real life. And we may have you do that from time to time if the numbers work out, right? F is another problem with just numbers, but this time notice like there's no minus. So first, there's no numbers in front. That's nice. So that means there's no powers. And then they're all additions. So that means they're all going to be multiplications. So that's 2 times 3 times 4. 2 times 3 is 6. 6 times 4 is 24. And again, if you wanted to put in a calculator, you could. If you do a change of base formula, you could do that as well. G, interesting. I have a plus, so there's a multiplication, but I have powers. And notice that these are different. So the 3 goes back to the 2. And the 2 goes back to this 3. So let me do this in steps. So that means I have log 2 with a 3 on top. And then I have log 3 with a 2 on top. And then we can simplify that because what's 2 to the third power? Well, that's 2 times 2 is 4 times 2 is 8. And then 3 squared. That's 3 times 3 is 9. But what's plus? What's plus mean? Right? We have to write this as a single logarithm. Don't stop there because you have 2 logarithms. So if it's a plus, that means you multiply. Just kidding. Never gonna give you up. So it's multiplying. Don't forget that. A lot of you are thinking like, what was wrong with 17? You have logarithms. And when you add logarithms, you multiply the arguments. So 8 times 9 is 72. This is a nice problem because you can just put down a calculator exactly how you see it and get an answer for that. part H, we'll need to go ahead and rearrange things first. So notice that there's a minus right here, and that would imply division. However, I'm strongly suggesting that you do the following. Put all your pluses to the left, all your minuses to the right. So that means I'm going to put this over here, right? So like, let's say log x plus log z minus 5 log y. So I want to go ahead and have all the pluses to the left, all the minuses to the right. And then if I do this, express it as a single logarithm, this is, of course, where my fraction begins. So there's a division. And here I'm having this argument is adding to this argument, so that means they're multiplied. And then over here, the 5 goes back to the y, and it's in the denominator. And if we want to be formal about it, we have parentheses. So just for kicks, here's a bonus problem, right? And notice how I have a mixture of minuses and pluses. So like I said before, let's move all the pluses to the left. So that's log x and then log a. And then let's go ahead and move all the minuses to the right side. And so that leaves me with a minus log y minus log b. And what happens is that this allows us to go ahead and figure this out better. We have x and a, they're being added. So that's going to multiply. The fraction bar starts right here. And then here we have b and y. Now you're thinking, okay, wait, they're not adding Mr. Over. Well, here's why. If I were to factor out a negative, you would see that I have a plus right here. Notice I picked up these parentheses. So if you distribute this negative, you would get a minus log y, a minus log b. So the minus is telling me, okay, this is a fraction, but then because I factor out a negative technically, I have now this b and this y that would multiply in the denominator. Now you don't have to worry about these technicalities if you don't want to. I personally don't. If you want to just keep in mind the little rule that I'm telling you, put all your pluses to the left, all your minuses to the right, and then all the pluses become your numerator, and all the minuses become your denominator. Don't complicate things, okay? If you want to just do that, then that's perfectly great. Which of the following is not correct? Problem 4, not correct, not correct. So addition means multiplication. 9 times 4. Interesting. B, 12 plus 3. That means 12 times 3. Interesting. There's a 2 in front. That means it goes back up as a power. So really we have 6 squared, right? Well, what's 6 squared? Interesting. 18 plus 18. That means I multiply. So what's 18 times 18? 18 times 18. Very interesting. So which one is not the correct answer? Well, do not delve deeply into disdain for the answer. Boom, boom, boom.